I have designed a self-balancing sushi build. So no matter how many inputs you have or what input flow rate you have, doesn't matter how many machines you have, how many power shards or Samos loops or whatever setup you have, the belt will always remain self-balanced. As you can see here, this is making rotors. We have screws, rods, and ingots just perfectly balanced. And I can go in here and tweak whatever, it doesn't really matter, it'll still self-balance. So how does this work and how do you set it up? The way to set it up is you want to have a priority merger coming parallel from all your machines with a priority of the center input set to high. So if we look here, all the machines have a priority merger with the center set to high. And then for the inputs, you just need to use a smart splitter to just filter off the item. Doesn't really matter the center output, just any is fine. And we can see here we're just filtering off our rods and our screws. So how does this actually work and what are the rest of these mergers and splitters doing? That's where the bread and butter comes in. So very importantly, you want to have your sushi belt be a faster belt than the belts coming out of your constructors or machines in general. So in this example, I have Mark III belts on the outside and Mark II belts coming out of the machines. So to set this up, what you want to do is you want to have the slow belts coming out of the machine and a slow belt coming out of this priority merger right here, which I'll explain in a second. And this belt is as fast or faster than the sushi belt right here. So what these are is you want to have a smart splitter branching off of the sushi belt with the same item type as what the machine is. So in this case, this constructor here is producing screws. So the smart splitter is going to have a left output of screws and a center output of overflow, meaning it's going to prioritize filling this belt with screws and any leftovers will be overflowed back to the main belt. This priority merger will simply have a right input set to high, meaning it's going to prioritize the screws coming off of this belt before taking in screws from this belt. And then that's going to come back onto the sushi belt. And as you can see, we have that for all machines and all inputs. So in this case, I just have a container filled with some iron ingots, and it's doing the same thing. We have the smart splitter going in, slow belt here, fast belt here, fast belt here. So how does this work? Essentially what happens is as inputs are coming through the sushi belt, they will be split off and they're going to block any future or new inputs from the machines. So if there's existing screws on the sushi belt, they will come in and block the constructor from placing more screws onto the belt. And the reason the belt speeds need to be different is because this belt being faster than this belt means it's going to prioritize replacing existing items back onto the sushi belt. If they were the same speed, and trust me, I did try, if they were the same speed, these would equally blow up the main sushi belt with the item. They will equally go into the merger. We want to have it prioritize the existing items. And this is going to naturally create gaps in the belt. As this slower belt merges onto the faster belt, there's going to be gaps from the inputs going onto the faster belt. Anyways, that's how it works. Let me know if you have any questions in the comments, and let me know if there are any improvements to the design. I'm sure it can be made more compact, more clean, whatever, but this is the gist.